The National Electrical Code, or NEC, allows engineers to mix calculation methods when sizing electrical services for multifamily buildings. This means different approaches can be used for individual unit feeders and the main building service. For individual units, the optional calculation method is often employed. This method uses specific empirical factors or demand factors to determine the feeder size based on the calculated load for each unit. These factors account for the typical usage patterns within a residential unit, leading to a more accurate feeder size determination. On the other hand, calculating the building service often involves determining the actual connected load for all units in the building. This approach requires adding up all the individual loads, taking into account lighting, appliances, heating, ventilation, and air conditioning, and other electrical equipment. While this method is generally considered more accurate, it can also be more time-consuming and labor-intensive, especially in larger multifamily buildings. A crucial element in determining the building service size is the application of derating factors. The NEC provides a table of derating factors specifically for multifamily building services. These factors are used to adjust the calculated building service load to account for diversity in a load. Diversity acknowledges that not all units within a building will operate at their maximum load simultaneously. This is because residents have different schedules, usage patterns, and energy needs. By applying these derating factors, the engineer can avoid oversizing the building service, which can lead to unnecessary costs and inefficiencies. By using the optional method for individual units and the actual connected load method for the building service, the engineer can leverage the advantages of both methods. The optional method simplifies the calculation process for individual units, while the actual connected load method ensures accuracy for the overall building service. This approach ensures compliance with the NEC while optimizing the design for efficiency and cost-effectiveness. It's important to note that while mixing calculation methods is permitted, the engineer must carefully document and justify their approach to ensure that the design meets all applicable code requirements and safety standards. This documentation should include the calculations used for each unit feeder and the building service, as well as the rationale for selecting the specific calculation methods and derating factors. In addition to these calculation methods, there are several other factors that engineers must consider when sizing electrical services for multifamily buildings. These factors include the voltage and current ratings of the service equipment, the available fault current, and the coordination of overcurrent protection devices. Engineers must also ensure that the electrical system is properly grounded and bonded to prevent electrical shock hazards. Proper grounding and bonding are essential for safety and can help to protect the building and its occupants from electrical damage. The NEC provides detailed requirements for grounding and bonding, and engineers must follow these requirements carefully to ensure a safe and reliable electrical system. Furthermore, the type of wiring and raceway systems used in the building must also be considered. The NEC specifies the types of wiring and raceway systems that are permitted for different applications, and engineers must select the appropriate materials based on the building's construction and occupancy. The wiring and raceway systems must also be properly installed and supported to prevent damage and ensure long-term reliability. The electrical service for a multifamily building is a critical component of the building's infrastructure, and it must be designed and installed to meet the needs of the building and its occupants. Engineers must carefully consider all relevant factors, including the calculation methods, derating factors, grounding and bonding requirements, and wiring and raceway systems to ensure that the electrical system is safe, reliable, and efficient. Here's a breakdown of how the optional method for individual units and the actual connected load method for the building service work in greater detail. The optional method for individual dwelling units allows for a simplified approach to calculating the service or feeder load. It is generally found in Article 220.82 of the National Electrical Code. This method is beneficial because it uses demand factors that recognize the diversity of loads within a dwelling unit. Instead of summing up all the connected loads at their full rating, demand factors reduce the calculated load based on the assumption that not all loads will be operating simultaneously. To use the optional method, there are some initial requirements. The dwelling unit must include electric cooking, electric space heating, or electric water heating. It also requires that the calculated load be at least 100 amps at 120 volts, or 24,000 volt amps. The basic calculation involves taking 100% of the nameplate rating of the air conditioning and space heating, if both are present, only taking the larger of the two. Then add 40% of the nameplate ratings of all appliances, including cooking appliances, dishwashers, clothes dryers, and water heaters. For all other loads, including lights, general receptacle outlets, and small appliance circuits, add 100% of their connected load up to 10,000 volt amps, and then 40% of the remaining load exceeding 10,000 volt amps. This calculated value is then used to determine the feed or service size required for the individual unit. Now considering the actual connected load method for the building service, this method is more comprehensive and requires a detailed inventory of all electrical loads within the building. It involves totaling the volt-ampere ratings of all equipment, including lighting, receptacles, appliances, HVAC systems, and any other electrical devices connected to the electrical system. After determining the total connected load, demand factors from NEC Table 220.42 and others are applied to account for load diversity. These demand factors reduce the overall calculated load based on the type of occupancy and the likelihood of simultaneous usage. For example, lighting loads in office buildings typically have a demand factor applied because not all lights are likely to be on at the same time. Similarly, receptacle loads in dwelling units may have a demand factor applied because not all receptacles will be in use simultaneously. The NEC provides different demand factors for various types of loads, and it is important to use the appropriate factors based on the specific application. After applying the demand factors, the resulting value represents the calculated load for the building service. This value is then used to determine the size of the service conductors, overcurrent protection devices, and other components of the electrical system. For multifamily dwellings, the NEC provides specific guidance on calculating the service load. Table 220.84 offers demand factors for dwelling units in apartment buildings and other multifamily dwellings. These demand factors are based on the number of dwelling units and account for the diversity of loads within the building. The table allows for a reduction in the calculated load as the number of dwelling units increases, reflecting the fact that not all units will be operating at their maximum load simultaneously. To use Table 220.84, you first determine the total connected load for all dwelling units in the building. Then, you apply the demand factor from the table based on the number of dwelling units. The resulting value represents the calculated load for the building service. For example, if you have a 20-unit apartment building with a total connected load of 500 kVA, you would apply the demand factor from Table 220.84 for 20 dwelling units. This demand factor might be something like 0.40, resulting in a calculated load of 200 kVA for the building service. Remember, it's crucial to consult the latest edition of the NEC for the most accurate and up-to-date information on electrical calculations and demand factors. Understanding these methods and factors is essential for electrical engineers and contractors to ensure the safe and efficient design of electrical systems in multifamily buildings.